Arnav Arora from EPH third year engineering physics, and today we are going to demonstrate the experiment using a light dependent resistance. So let us come to the setup. The setup basically consists of a module in which there is an option of a power supply, a voltmeter and an ammeter, and a simple circuit has been connected with a light dependent resistance which to which the light can be sent through this armature here. So first we will make some simple connections. We will connect the source to the LDR circuit. We will connect the voltmeter to the parallel connection given for voltmeter in the module, and we will connect the ammeter in series. So now our system is ready for measurements. Let us try to, through this source we can increase the voltage of the system with the help of this knob. Let us try to increase the voltage and see what happens. So as you can see, we are increasing the voltage, and this can be displayed in the voltmeter, which shows that the voltage applied to the circuit is increasing. However, there is no corresponding increase or decrease or any change in the magnitude of the current. We can increase it further, and we have taken it to the highest value it can attain now, which is 2 volts in this setup. Still there is no change in the current. From this we can make a very simple conclusion that this circuit is open at some place, or some element in this circuit has a very high resistance and it is not allowing current to pass through it. And of course that element is the light dependent resistance. A light dependent resistance, when it is not exposed to any light, is in a high impedance state, which is the case here, and that's why it is acting as a very high resistance, and the circuit acts almost as if it's open, or a very negligible amount of current is passing, which is so sensitively small that it cannot be measured by the ammeter here. So we just concluded that this circuit is an open circuit, and it is probably due to the high resistance mode of the light dependent resistance. So now let us try to shine some sort of light energy into the resistance and see what is the behavior. For this we will be using a simple flashlight from our smartphone. So now we are shining a light on the resistance, and at the same time we try to increase the voltage, and as you can see now, upon increasing the voltage there is also an increase in the current. This means that the circuit is able to conduct electricity, and that the resistance attached to it is not extremely high, which causes the circuit to behave as if it's open. And once the light is applied to it, it shows normal resistance behavior, where an increase in voltage corresponds to an increase in current which is passing through the system. So now let us analyze what happens as the intensity of light falling on the LDR changes. So for this we have set up the voltage to be constant at a value of 1.05 amperes. And what we will be doing is that we will be increasing the distance between the light source and the module. As the distance increases, the intensity of the light that falls on the LDR decreases, because intensity falls as 1 by r squared in general. And let us see what happens then. So currently the value of the current passing through the circuit at 1.05 volts is 0.08 milliamps. Now we slightly increase the distance and it becomes 0.07 milliamps. As we increase more, it becomes 0.06 milliamps, 0.05 milliamps, and it keeps on decreasing until it reaches a value of until it reaches a value of 0 milliamps. So we can see that as the distance increases, the current falls. This is because as the intensity of the light that is falling on the LDR decreases, the resistivity or the resistance of the LDR keeps on increasing. This is because it operates on a simple model where carriers are excited as light falls on it, and if less and less intense light is falling, means less amount of photons are falling on the LDR and less carriers are being generated. And that is why this proves that as you decrease the intensity, the resistance increases and the conductivity decreases.